All right, here we go again. Good afternoon, good morning, whatever, to anyone who's out there watching this video. I think one person watched yesterday, so whoever that was, maybe comment on, well, I don't want to be able to tell, so never mind. Just if you want to keep learning, this is the way to do it. All right, so wrapping up section 5.4, the second part of this is what's called trig identities. Trig identities are widely hated by all students everywhere, so you're fortunate to not have to do this, but it's a fun thing to play around with. So what we're going to do with trig identities is we're going to take something like the one above, secant divided by tangent, and we are going to, I'm going to have to find a better way to do this, and then we are going to change that into another trig function. So how this goes is I know that secant, for example, is the inverse of cosine. So I'm going to rewrite it as 1 divided by cosine. And then I know that tangent is equal to sine divided by cosine. So I'm going to rewrite it as sine divided by cosine. Now for all of you watching out there whose heads are immediately spinning, maybe we should take a second to write out all the identities that we know. I think that they are in the notes. Yeah, right here. So this is what I am going off of. I know that I can write tangent as a couple of different things. I can either write it as sine, oh yeah, so tangent I can write as sine over cosine. Secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is the one that I can write two different ways. I can either write that as 1 over tangent or as cosine over sine. So in the, let's grab these so we can have them available to us throughout the day. I'm going to grab these and I'm going to throw them onto this page over here. And then that way, whoops, that way we can easily refer back to these when we have to, just like we did yesterday with our special triangles. So what I did, again, is first I wrote something really horribly disgusting. Then I said secant is 1 over cosine, and tangent is sine over cosine. And notice that I'm not writing the variable in there, and that's because I am limited by this computer as to what I can write, and I don't want to deal with it. Okay, so now we have 1 divided by cosine, and that's being divided by sine over cosine. Well, I'm sure you remember that when you're dividing by a fraction, what you do is you multiply by the reciprocal. So you multiply that by cosine over sine. And in this case, then, since this cosine is on the bottom and that cosine is on the top, those two things cancel. And that leaves us with 1 divided by sine, which we could go back and look at these identities again. 1 divided by sine is the same as cosecant. And so in the end, what I have done is I have taken secant divided by tangent and rewritten it as cosecant. Okay? So that's what trig identities are all about, is starting with one thing like this and rewriting them as a different one. Okay, and so what we're pointing out here is that once we've shown that, then we know this is true, and so we can use this anytime we want if it would help us. Okay. All right, so let's try another one. Let's show that 1 plus cotangent divided by cosecant is equal to simple sine plus cosine. Okay, so first step, just like in the other one, is I am going to rewrite these things using our basic identities. So if I go back here and I look at cotangent, cotangent is 1 over tangent, but it's also cosine over sine. I'm going to go ahead and write that as cosine over sine because my final answer, I'm trying to get cosine and sine. So if I can, get something going with that, in here to start with, then that'll help me. Whereas if I write it as 1 over tangent, that's not necessarily going to be very useful, okay? So 1 plus cotangent I can change into 1 plus cosine over sine, and then cosecant, again, going back here, I can change into 1 over sine. So that means I can, where did you go? Ah well, that means I can write this on the bottom as 1 divided by sine. And so that we know that we're dealing with an actual fraction here, let's pull a fraction bar there. Okay? Alright, then from there we're going to do the same, oh no, before we do the trick that we did on the last one, I need to rewrite this as a single fraction. So in order to do that, the first thing I'm going to do is I'm going to get a common denominator. So I'm just working with the thing on top here. So my common denominator between these two terms will be sine. So 1 is the same as sine over sine. And then cosine over sine I don't need to change because I already have sine on the denominator, and that is still being divided by 1 over sine. Aren't you glad that this is not required work? Okay, so now that I have a common denominator on top, I can rewrite that as a single fraction. So sine over sine plus cosine over sine is going to equal sine plus cosine divided by sine. And I still have, on the bottom of this fraction, 1 over sine, okay? Alright, so then I'm to there. Now I can do the trick that I did before where I multiply by the reciprocal. So my fraction on top is sine plus cosine divided by sine. And I'm going to take that and multiply it now by the reciprocal of 1 over sine, and the reciprocal of 1 over sine, conveniently, is sine, let's see, what's the best way to write this? Divided by 1, okay? Sorry, Dylan, I know that parentheses would drive you, that hanging parentheses would drive you batty. Alright, so let's clean this up a little bit. So I have this fraction right here times this fraction right here. So once again, sine on the bottom, sine on the top cancel, and what do you know? That leaves me with sine plus cosine, which is what I was trying to get it to equal in the first place. Isn't that a ton of fun? Alright, do we have any more? Sure. So let's do another one here. Now this is a fun little strategy where I have cosine squared divided by 1 plus sine equals 1 minus sine. So what I'm going to do for this is I am going to think of this as being 1 minus sine divided by 1. And then I am going to cross multiply. So I'm going to multiply this times that and that times that. So when I go this way, that is super easy. Cosine squared times 1 is cosine squared. Going the other way is a little bit more complicated, but not too much, because you should recognize this as the factored form of a difference of two squares. So first times first, 1 times 1 is just 1. If I did the outside terms together, I would get negative sign. Inside terms together would be positive sign, and those would cancel. So this would be negative sign, and then I would have a positive sign, and then those would cancel. And then if I do sine times negative sign, then I get negative sine squared. Okay? Alright, so like I said, the negative sign and the positive sign cancel each other out. And then this would be cosine squared. If I add sine squared to this side here, then I get cosine squared plus sine squared equals 1. But we already know from our Pythagorean identity that cosine squared plus sine squared is 1. So I'm left with 1 equals 1, which is true. So that's us using the Pythagorean identity to come up with a different dealio. You having fun yet? Are you glad that you logged in and watched a quick math video? Okay, we could do, then the last thing that is actually a little bit important is that if we start with, let me pull a new page here. If we start with that world famous Pythagorean identity that we just ended with on that last page, which is that sine squared plus cosine squared equals 1. There's two different things that I can do with this. The first thing that I can do with this is I can go through and divide everything by cosine squared. So let me get some cosine squareds up here on the screen. And then let's see what happens if we take and divide all of these individual terms by cosine squared. Alright, so if I take a look at this first one, sine squared divided by cosine squared, well, I can go back to my identities here and know that sine divided by cosine is tangent. So that means that sine squared divided by cosine squared is tangent squared, plus cosine squared divided by cosine squared is obviously just 1. And then if I go back to these identities again, I can see that 1 divided by cosine is secant, which means that 1 divided by cosine squared is secant squared. And so that is another trig identity that I can get from the original Pythagorean identity, sine squared plus cosine squared equals 1. Okay, the other way that I can go with this is I can go back to the beginning and take sine squared plus cosine squared equals 1. And this time I can divide everything by sine squared. And we can see what happens. Can you guys hear that music in the background? Can't tell if you can or not. Okay, so I'm going to divide everything this time by sine squared. Let's be a little bit more thoughtful about how we make our fractions this time. So I'm dividing this, I'm dividing this, and I'm dividing this. Alright, so as we did before, sine squared divided by sine squared is 1. Cosine squared divided by sine squared, if I go back to these identities here, cosine divided by sine is cotangent, so that means cosine squared divided by sine squared is cotangent squared. You guys would be so mad at me right now if we were doing this in class, but you can't yell at me because I'm at home. Haha. And then 1 over sine is cosecant, so 1 over sine squared is cosecant squared. Okay, so by doing a little witchcraft with sine squared plus cosine squared, we get 2 new trig identities. And if we were in my room at school, I would point out that on the poster in the front of the room, we have all 3 of these on the same piece of paper because they are all related. So let's see, I think they summarize it all right here. Okay, so the alternate forms of the Pythagorean identity, we know the regular form is sine squared plus cosine squared equals 1. We can switch that around to get 1 plus tangent squared equals secant squared, and then we can also do cotangent squared plus 1 equals cosecant squared, so those are sometimes useful. Okay. Alright, I'm not going to mess around with any of that. So this is kind of what we learned in this section. There are 6 trig functions altogether: sine, cosine, tangent, cosecant, secant, and tangent. They're all related to each other in various ways because they come from the same right triangles. And then today we pooped around a little bit with some trig identities. So if you are a glutton for punishment, here are some problems that you can try. You can see by the clock here that it is Friday afternoon at about 3:50, and I am tired of making math videos by myself in my bedroom, so I'm going to wait and go through the answers to these with you on Monday. So you can try these if you want. or you can wait until Monday. But again, none of this really matters. Not required. Send me an email if you want to give me any feedback. Otherwise, have a great weekend. Take care of yourselves, and we'll do it again sometime.